Hello everyone and welcome to my video about where we will learn what is the distribution of a continuous variable, how do we represent the distribution of a continuous variable. So this would be the video 1.1. I will show later the contents of my course so that you don't get lost where we are. At the minute, we are just interested in focusing on continuous variable. So continuous variable is a numerical variable that can take any number, like you allow decimal points as well. For example, the weight of the people, the height, and so on. Don't forget to subscribe to my channel, and if you have any questions, I am giving you the email in the comments below the video. Okay, so let's start by going back to the type of graph for any statistical analysis that you may want to do. So the distribution of a numerical variable, so a continuous variable. Let's say for a discrete variable, you can use the same method basically as for continuous variables. Just usually we have continuous variables in data sets and so on. You would equally represent a discrete variable with a box plot or a histogram as well. Just the majority of the numerical variables that we see usually they are continuous variables. So that's why I put the beginning of the video. The title of the video is about the distribution of continuous variables. We will see, first of all, what a box plot is, what are the borders of the box plot, what do they mean, and so on, the histogram, and we will see a few statistics, a few descriptive statistics. Here, if I zoom a bit more, so we're in the distribution of a numerical variable, we will first see a box plot. What is a box plot? This type of graph, and a histogram. Okay, histogram, which is here. So we are just looking at one numerical variable, okay? In a data set, you may have 20 participants or 2,000 participants. Each participant has a score, like the height, for example, how tall they are, and the height will be a numerical variable. Moreover, it would be continuous variable. We will see how to represent the distribution of the continuous variable of the height among the 2,000 participants that you have. You either plot a histogram or a box plot. Okay, these graphs are made in ggplot in R. So most of my course is made thanks to R. I have some graphs made with SPSS, some other with Python as well. But whenever I want to use a software, I will use R and ggplot because I think the graphs are quite nice looking. But the most important is to understand what the graphs mean, okay? The statistics, so the mean, the median, the mode. So we will see that's the descriptive statistics that you should report when analyzing a numerical variable. You should analyze, you should give the Q1, the first quarter, the third quarter, and so on. So let's go back to this, distribution of a numerical variable. We will just focus on this first row of type of graph for my analysis. So we will analyze the distribution of a numerical variable in a data set. It depends. So you have several data sets in the world, so you will have several ways of measuring the distribution of a numerical variable. Of representing, the distribution of a numerical variable. So let's get started. So first data set. So the first data set, we start by first seeing this data set. So it's US arrests in R. And basically, these are variables about crimes in the 50 52 states of the USA. I don't remember if there are 50 or 52, sorry for this. The states here, so each row represents a state, okay, of the US. So state number 1, state number 2. The murder rate in state number 1 is 13.2 per 100,000 inhabitants, okay? So that's a continuous variable, okay? This is a continuous variable. Assault is also a continuous variable. It's the number of assaults. The urban population is in percentage, 58% of the population in that state live in a city. The rape is the rape rate, okay? So it's a continuous variable as well. We only have continuous variables in this data set, okay? Each row represents a participant, and each participant here is a state of the USA, okay? So we have 50 states, and they are all here, okay? This data set is in R, okay? So if you install R in your machine with RStudio, you will have this data set. The most important is to understand the graphs that I'm going to show you and the few descriptive statistics to report when you want to describe the distribution of a numerical variable, okay? The data set is less important. It's just I want you to understand how to read a data set and how to represent the distribution of a continuous variable. What can you say about the continuous variable murder rate in that data set, okay? So don't forget that the participants are the states here. So we will represent the column murder by a box plot. So this is the murder column, the murder rate, okay? So it's a variable, okay? A continuous variable which changes values according to the participant, according to the state, okay? You have 52 states, so you will get like 52 rows here with 52 values, okay? It's just that the slide is not big enough to represent all of them. So I choose to represent the distribution of murder rate by a box plot. Let's have a look. This is the box plot of the murder rate made in ggplot in R. So we have 50 states in the USA. The participants here are the states. The response variable is the murder rate, as I said, okay? Murder arrests per 100,000 people, inhabitants. So we have an upper whisker here, okay? So I call it upper whisker because in many software there is a horizontal line here that we call a whisker, and this is the upper because that's the top one, and the lower is here. We will first look at the median. The median is the number corresponding to the horizontal line in the middle of the box. So, I mean, it's not exactly the middle of the box. It's the value of the median. The median is the value for which 50% of the data are below. That is 55 states below that value, which is about 7.2, something like this, okay, 7.2. It's just to show you how the data is distributed, how the murder rate is distributed, okay, among the states. So you have 50 states. So 25 states have a murder rate below 7.2, okay, per 100,000 inhabitants, and 25 states have a murder rate above 7.2 murders per 100,000 inhabitants, okay? Q3 is that one. Q3 is called the third quartile because you have 3/4 of the data, that is 75% of the data of the states that have a murder rate below the number that is reported on the y-axis. So the y-axis is the murder rate. The y-axis is, oops, it looks like an X, sorry for this. Y-axis is the murder rate, okay? The y-axis is the murder rate. So 3/4 of my states are below the value of about 11, okay? You can get Q3 directly in R or in any software like SPSS. Q3 of murder rate column, you will get the value of that Q3. It will be about 11 something, 11.1 maybe. This tool is just to visualize about where is Q3, where is Q1. Is the median closer to Q1 than Q3? Yes, it is, okay? So Q1 is the first quartile. So it's the value for which a quarter of the data are below, okay? The lowest quarter of the data is here. And we have 25% of the states, so 25% of 50 states, it's well, a quarter of 50 states, it's about 12 states. 12 states are below the value that is here. This value is Q1. Q1 is equal to 4.4 maybe, okay? I don't really care about the exact number here. It's just to show you how to read a box plot, okay? So the line in the middle is not the mean, okay? This is the median. The median is also Q2, second quarter, 50% or 2/4 of the data, that is half of the data, is below. So the lower whisker, when there are no outlier, is the minimum of the data. So the state that has the smallest number of murders per 100,000 inhabitants. So that's when there is no outlier. The upper whisker is the maximum of the data when there is no upper outlier, okay? So here there are no outliers. This is the value of the state that has the most murders, okay? The highest number of murders. So, hopefully you have got a better idea of what a box plot is here, okay? It represents the distribution of the continuous variable that is on the y-axis, and then after that you can see where Q1 is, where the median is, where Q3 is. There is no mean in that. There is no standard deviation. It's just like it ranks the data. It takes the 25% lowest that are below Q1, 50% lowest that are below the median, 50% highest that are above the median, and the best quarter is, the highest quarter is above Q3, and so on, okay? So when do we have outlier? So how do we define outliers in statistics? So let's say we have the age death of 12 people, okay? You have 12 people in a group. So let me get back to it. You have 12 people in this group, and you have registered the age of their death, okay? Most of them, they die at around 85, 90 years old, okay? Age of death is this, okay? So that's the y-axis representing age death. We represent the distribution of age death of these 12 people, okay? So I got 9 here, but I will add like 2 of them. Yeah, I have 12 people and have registered their age death, the age at which they died, okay? So let's imagine that, so most of the people, they die below 100 years old, okay? You have the median that is 90. So in this group, it means that in this group you have 6 people, so half of 12 people, 50% of 12 people, that is 6 people, have died before 90 years old, because that's the median. The line in the middle is the median. You have 3 people. 3 people is a quarter of 12 people. 3 people have died below Q1. Q1 will be maybe 86. Again, like you get your column of 12 values and you can get Q1 directly with R or with SPSS or whatever software you may use. You can even get it online, like in a website, if you copy paste your data set. Okay, this will be, it's just here to see how to read a box plot. Okay, I don't really care about the exact numbers of this. Just you have to know that this line you report on the y-axis, Q3, it would be, for example, 92, and you would have 9 people out of the 12 people, so 3/4 of 12 people is equal to 9 people will be below 92 years old. So 9 people out of the 12 people in total in my group will have died before 92 years old. Imagine you have one guy or one woman, because usually women live longer than men in general, 1 or 2 years longer. So let's imagine a woman, for example, a person, dies very, very late, like at 117 years old, okay? So that person is an outlier because it's too abnormal compared to the majority of the population, okay? How do we define an upper outlier in math, in statistics? It's by taking Q3, so 92 years old, plus 1.5 times IQR, which is the interquartile range. The interquartile range is, so the interquartile range, which I haven't talked about in my previous slides, is Q3 minus Q1. Okay? Anything that is above Q3 plus 1.5 times IQR will be an outlier. Okay? So this would be an outlier. Okay? Anything below Q1 minus 1, here there is a minus 1.5 times IQR, interquartile range, will be a lower outlier. It could be somebody who dies at 21 years old, for example. It's too soon to die, okay, compared to the majority of the population of the group that we have here, okay? So be careful, check that there are outliers before saying that this is the minimum and this is the maximum. This isn't the maximum. The maximum here is your upper outlier, 117. You may have several upper outliers and you may have several lower outliers. You may have no upper outliers and you may have no lower outliers. It depends on your data, okay? So here, as I mentioned, interquartile range represents, like, so 50% of the population, 50% of the group that you study of your data set, 50% of the states are between Q1 and Q3, okay? The length from Q1 to Q3 is called the interquartile range, okay? Q3 minus Q1. So you have 50% of the states of your participants that have values between Q1 here and Q3 here. So you have 25% below Q1. Okay, no problem. So this is Q1, of course. This is the median, or Q2. We can call that Q2, but we call it median usually. And then Q3. Okay, so I know that I have 50% below the median, okay? Whoops, 50%, sorry. 50% below the median. And I have 50% above the median. So it means that between the median and Q3, I have 25% of the data of the states of the participants between the median and Q3, and 25% of the data of the participants of the states that have a murder rate between Q1 4.2 and median 7.7, for example. Okay, so that makes 50% in the box, 50% outside the box. Okay. Now the range, we also sometimes talk about the range in stats. It's simply the maximum minus the minimum. Okay. It will give you, it's a measure of spread of the data in a way as well. It's quite it's quite a weak information about the spread of the data, but it can help sometimes to see where your data lie. Okay. All this information range, interquartile range, median, Q3, Q1, are statistics, are descriptive statistics about your data set, about your column murder rate, that you should report whenever you represent the distribution of a numerical variable, such as the murder rate here. Okay? So the range and the interquartile range. So usually you would represent the median, the Q1, Q3, the number of participants as well, the interquartile range, and the range, okay? For one numerical variable, okay? Let's now review what a histogram is. So, we will represent now the number of murders per 100,000 people in a state by putting it in the x-axis this time. Histogram is the other type of graph to represent the distribution of a numerical variable. And this is what you should do if you want to see if your data is normally distributed. That's also a question that arises for which type of test you should use. Is it a parametric test or a non-parametric test? Okay. So we will see that in a future video. The x-axis represents the measurement, murder rate per 100,000 people. It is subdivided in a certain number of equal intervals that we call bins, B-I-N-S, okay? This is automatically done in any software. So here it's SPSS that is used. They have subdivided the interval automatically. They thought that it was the best subdivision to better visualize your distribution. But in most of the softwares, most of the packages, you can decide the number of bins, okay? So what is in a bin? What is in an interval? For example, in that interval, so 15 to 15.216, for example. You will have 3 states. It means that you have 3 states between 15 and that number here, let's say it's 16.25 murders per 100,000 people. So 3 states, the frequency is the count of states per subdivision of murders, okay? So between 0 and 5, you would have 1 plus 4 plus 6, so I have 11 plus 5, 16 states that are, so 16 states that are that have a murder rate between 0 and 5 murders per 100,000 people. So for each interval, for each bin, okay, for each sub-interval, we count the number of states that have a murder rate between the beginning of the interval and the end of the interval. So here it will be 10 towards 11.25, okay? And so on. So you represent your 52 states here in that histogram. So for those who are more, who want to know about the normal distribution, if you want to check that your data is normally distributed, you just look at this histogram and see if there is about a bell shape, okay? Whoops, sorry for this, I will do it again. So we are looking for a symmetric curve. If you want to check if your data is normally distributed, okay? What matters is that it is not too extremely not normally distributed. So if it is like this, for example, go for non-parametric. But if it is if it is okay, like here, it would be maybe fine to use a parametric test, okay? But let's check that in future videos. At the moment, just know what a histogram is and what a box plot is. So here, as I mentioned, just a slide to present to you again. In fact, a histogram is a bar chart where each bar is a count in a certain area of murders. So between 15 and 16.25 murders per 100,000 people here, I have 3 states, okay? As I mentioned below, you have a Gaussian function that can be represented here. So we will see that in a later video. That function is perfectly symmetric, and if it fits well with your histogram, it means that your distribution can be modeled by the normal curve. It means that your distribution, you can consider your data to be normally distributed and to use a parametric test instead of a non-parametric test. But forget about that if at the moment you haven't understood what a histogram is or a box plot is. At the moment, understand what a box plot is, how to read a box plot, and how to read a histogram, okay? This will be for future questions, okay? Future videos. So let's go back to some descriptive statistics that you should report in when you want to report the distribution of a numerical variable. So I would suggest you to plot a histogram and a box plot, both of them, to report the median Q1, Q3. So the median, I already explained what it was. The mean is the average mean, is the sum of all the values divided by the total number of participants. So that's the average that you probably know what it is. Not to be confused with the median, okay? The mode is the most frequent value. In general, it is more used for categorical data. So at the moment, I mean, when you have when you have a continuous data, I would suggest not to look at the mode, but more the mean and the median. Okay. So if your data is skewed, for example, salary of a population, so the difference, the mean will not be equal to the median in that case. So let's say you have the salary of the population is more represented like this, usually. It is very skewed in general. Let's say you have a group of 20 people. Most of them, they earn less than 5,000 which currency? Well, let's say euros. So less than 5,000 euros, like the 20 people. So you have 20 people here that earn less than 5,000 euros. In your group, you have a 21st, so number 21 that earns like €1,000,000. Let's say it's a famous actress who earn €1,000,000. If you do the mean will be much higher. You will sum all the salaries divided by 21. All salaries divided by 21. Really sorry for the handwriting in the mouse. So this will be very big. It will be more like, because of that person, €1,000,000, it will be close to maybe, let's say 80,000 euros per month. So you would conclude Just if you had reported the average mean, that's why you need to be careful when you read newspapers. You will understand that if you just report the mean, oh, 80,000 euros in average salary per month for that group of 21 people, it's really great. I want to live in that country. If you report the median, it's more accurate, okay? Because here the median, it's the value for which half of your group is below, okay? So about, you know that half of your group will earn less than 2,200 euros, okay? So the median will represent much better the group than the mean in that case. It's better to have reported only the median than to have reported only the mean, because if you had reported only the mean, this is something that is that doesn't give you the right information about the group. You wouldn't conclude that, oh yeah, about everyone earns like 80,000 euros. The median is more informative. Actually, I would have given also Q3 to show that Q3 would have probably been 3,000 euros. Like 3/4 of this group earn less than 3,000 euros. So be careful when you see statistics about, especially about wages and salaries. Just have a look at the median, have a look at the third quartile, and the outliers, because this millionaire here, this millionaire actress here, is really an upper outlier. So the median takes into account the outliers, okay, in the information. So it is better to use the median when you have skewed data such as salaries. When it is symmetric, a bit like the murder rate before, you can use mean in that case. But for an example of skewed data like wages, it's much more better to report the median and the first quartile, the third quartile. Lastly, when you have not a skewed data set, so more like a murder rate, you can show the spread of parametric data by showing the standard deviation. So the standard deviation is the square root of the variance of a column of measurements, such as the murder rate, for example. It is in the same unit as the measurement, so that's why we often report the standard deviation. It is used when your measurements look normally distributed, so when they are symmetric. When you have data that it looks symmetric, you can use like parametric tests, and you can consider your data normally distributed. So the standard deviation, it's the measure for which 68% of the measurements in the population are expected to fall at the mean plus or minus 1 standard deviation, okay? So you would use a standard deviation when you have symmetric data set or normally distributed data set, okay? It means that 68% of the measurements are falling between the mean plus or minus 1 standard deviation. The range, or the interquartile range, is more used when you have data that are not normally distributed, that are skewed, that are like the salaries, okay? So in any case, if you just want to look at the distribution of a data, just do everything. Report the range, interquartile range, the box plot, the median, Q1, Q3, and the mean and the standard deviation, okay, the number of participants, okay. Everything is in the video and should be okay. I hope it clarified a lot of mysteries around the box plot and the histogram. And well, the last slide, sorry, I haven't talked about. It's just repeating what I just said. Basically, the data looks symmetric. The mean is approximately equal to the median. So, well, it would be better to represent the mean, whereas for skewed data, it's better to use the median. Okay. So thank you very much for your attention, and don't forget to subscribe to the channel. And if you have any question, please, you can send me an email to the email address that I put in my comments below. So I hope, I wish you a very nice day or a very nice night if you watch me on in the evenings, it depends. And hope to see you soon and you enjoyed this video. Okay, see you.